Alright, I think that maybe differentiation would be something you can manage. Okay, it's just that there are new rules that you have to learn first. Okay, it is very standard, alright, in terms of the routine. So I figured that you all can manage routines better. Okay, so the first rule that we will learn, okay, is the power rule. The name honestly doesn't quite matter. Okay, in my life, alright, subsequently I only remember what is called quotient rule and product rule and chain rule. Okay, power rule, constant multiple rule, sum rule, difference rule, all these names that you see in your textbook. Okay, it's not going to be commonly said now. Alright. So first one, power rule. Okay, so what it tells us is that when I have things like y equals to x to the power of n, okay, the derivative, which is what we write as dy over dx, okay, I'll talk more about dy over dx in a moment, that will be equals to bringing down the power times x power minus 1, okay, so bring down power, then minus 1. Okay? So, differentiation. What exactly is it? Okay. D over dx, this fraction over here, it is a notation that adds something like your plus minus times dy. Okay, it is a notation that behaves like your plus minus times dy kind of thing. It is not an algebra. It does not mean different d times y over d times x. Then end up you cancel, tell me y over x. No. Okay? It's not your algebra, yeah? Okay? It is just a notation to tell us that we are differentiating y, okay, over with respect to x. Okay, so how do we read this? We differentiate y with respect to x. Okay, so the top part refers to differentiate y, bottom part refers to with respect to x. Okay, it can be with respect to many things. Okay, so for example, if I have my y equals to maybe p to the power of 7, right? Then there's no x for us to talk about. So how we change the notation accordingly will be that dy over dp. We will differentiate with respect to p, okay, and I will get 7p to the power of 6. Okay, but most of the time we are dealing with x for now, okay, until we have more context in the question. So an example to the power rule will be as such. Okay? Any questions? Right? So this is one notation regarding differentiation. There is another way of representing differentiation. Okay? So what other way am I referring to? It is instead of saying y equals to x to the power of n, when we study polynomials, we sometimes use fx as well. Okay? So if I say fx equals to x to the power of 8, then how am I going to use this symbol? We are not going to be doing things like that. Okay? Because it's very confusing. Because this itself is a notation, fx itself is another notation. Okay? So to simplify things, we will instead write f prime x. This one we call it a prime. Don't tell me power of 1, okay? So it's not f to the power of 1x, huh? Okay, so f prime x is equals to, in this case, 8x to the power of 7. Okay, so this is another way of notating, okay, having a notation for differentiation. Right? Any questions? So I introduced to you the power rule, as well as the notations that we are going to see very often. in try 1, okay, the textbook page 5, you want to find dy over dx if y is equals to x to the power 20 and if y is equals to 1 over x to the power 40. Okay, so if y is equals to x to the power 20, what is dy over dx supposed to be? Say, what do you think? X to the power 19. Very good. Okay. Next one, part B. Y equals to 1 over x to the power of 40. Any ideas first? Wei Chan, what do you think? Wei Chan, oh, sorry, Wei Na. Why did I say Wei Chan? Wei Na, yes. My apologies. Okay, so Wei Na says negative 40 x to the power of negative 41. Okay, so how did she arrive at this? Right, so it is because notice that this is of a different form from what I gave as the rule. Okay, what I gave as the rule has only x. Okay, it doesn't have 1 over x. So what we got to do is to apply our indices laws. Instead of 1 over x to the power 40, we need to re-express it as x to the power negative 40. Okay, so x to the power negative 40, then it matches with our rule. Then we can bring down the negative 40. Negative 40 minus 1, take note, is negative 41, not negative 39, which is a common mistake. Okay? Any questions? No one? So this power rule itself, I didn't quite put it inside the formula booklet independently, but I wrote it under the chain rule part. Okay. So next, we look at the constant multiple rule. Okay, or the constant rule as well. Okay, so what the constant multiple rule says is that if I have, let's say, y equals to k to the power of fx. Okay, so what if, I'll give you an example like easier to see. Okay, constant multiple rule is if I have 7x to the power of 6. Okay, so then what is going to happen? Right? When we have a constant in front, we keep that constant in front. Okay, it doesn't affect anything, so the 7 it remains there. Okay, what we have to do is to only differentiate the x to the power of 6. So dy over dx will be 7. Keep it there. Bring down the 6x to the power of 5. Okay, then we multiply 7 and 6, we get 42x to the power of 5. Then after that, constant rule. For constant rule, right, we have, let's say y is equals to 5 itself. Then how do we go about differentiating? Because there is no x in it. Okay, so our derivative dy over dx would be 0. Okay, to explain why this has to be the case, it is because if I think carefully about the constant y equals to 5, it is the same as writing 5 times x to the power of 0. Agree? Because x to the power of 0 is 1. Okay, so 5 times 1. So if I were to differentiate it, okay, I bring down the 0 according to my constant multiple rule. 0 minus 1, okay, I will get negative 1. But 5 times 0 will make everything 0 already. Okay, so that's why no matter what constant is it, your derivative will always be 0. Okay, So that will be the constant multiple rule and constant rule. Okay, now try to, given that y is equals to 8x to the power of negative 5, we want to find dy over dx. Pervin, can you give me the answer for part A? Pervin, can I get the answer for part A? I want to differentiate y equals to negative 40 x to the power of negative 6. Okay, good. So we bring down, so how we got this is that we bring down the negative 5 and then minus 1 to the negative 5. Okay? And then we get negative 40x to the power of negative 6. Okay, then what about part B? What could we be getting? Kenneth, what do you think? You want to re-express B as in re-express y first? Is it? Sorry, what I saying? Oh, okay, so y will be equals to? Yeah. Then square root. Oh, okay, so the same question. Then? 2 over 3 to the power of 3 over 2. Okay, good. Then, anything else? dy over dx? Okay, 2 over 3 times 3 over 2. Yep. Okay, so we would get x to the power of half, or you could write it as square root x. Okay, so the thing about part B is that because we also do not have any rule at the point regarding square root, okay, but we can use our Indices Laws, right, that we are familiar with to redefine our square root to change it as a number, okay, in the power. So we get x to the power 3 over 2. Only in this stage, then we can do our differentiation. Okay, so where we bring down the 3 over 2 and we minus 1 to the power. Right? Okay, so in try 3 we have y equals to 1.001x. What would the derivative be? Nicole, what do you think? What's the derivative for 1.001x? Anything else? No, so that's the answer. Is it? Okay. An answer, right? Okay. Sometimes when I ask you whether is it answer, please give me a nod or a shake so that I can tell. You will give me an I don't know, okay, what you all are saying, and then you all sometimes mumble yes, no, with that look, I cannot figure it out. Okay, so it helps me with a knot or a shape. Okay, so in this case, yes, this is the answer, but how? Okay, because this is x to the power of 1, so we bring down the 1, right? Okay, will be 1.001 times 1. And then after that, the power of 1 minus 0, okay, would, sorry, not 1 minus 0, 1 minus 1 will be actually 0, so that is the reason why we will get 1.001, okay. So of course, now only at the beginner stage, I will be writing this, okay. Later on, I'm sure you'll be exposed so much to such a thing, you will know that whenever you differentiate something that is of the power 1, you will only be left with the constant, okay. Then after that, in part B, what is the answer going to be? What's the answer? Wait. 0, okay? So that's a constant number. Alright, no x with it. Next, now that we have looked at individual single terms only, of course we are not going to be looking at such expressions only, we will be looking at an entire polynomial or an entire expression with plus and minus in it. So we need to know how to differentiate expressions as well. So we introduce the sum rule and the difference rule. Okay, so the sum rule and difference rule is fairly intuitive, whereby u and v, let's say that they are actually functions representing x. So maybe to not make things so difficult to look at. Okay, let's say if I have x to the power of 5 minus 7x to the power of 2, sorry, plus 7x to the power of 2, okay, what we will be getting out of this is that we can differentiate it individually where there's a plus, we continue the plus in the given expression. Then after that, we will be getting 5x to the power of 4 plus 14x. Okay, so the sum rule is an intuitive one, where you are given expression, just differentiate individually. But in working wise, you do not need to tell me this lengthy step here. Okay, so going from here to here is an expectation, right? So just writing this out as a rule for you to see for now. Okay. Then similarly, when it comes to the difference rule, if I have to differentiate x to the power of 5 minus 7x squared, it will be to differentiate individually as well, just that the operation follows, and I would be getting this 5x to the power of 4 minus 14x. Okay, so only the sum rule and difference rule is intuitive. Okay, later on when I introduce the product rule and the quotient rule, it will not be intuitive like this. Lesson end 3:40. Oh dear. Okay, finish this question, then we're done. Okay. So fx is given as that. What will the derivative be? Zhiquan, what's the different derivative going to be? Or you want to simplify fx first? Hello. Sorry? X to the power of? Okay, 10x to the power of 4, followed by, really okay? Followed by, you want to rewrite this one first? Or will it be rewritten as? X power negative 3, is it? Okay, plus pi, followed by the differentiation is how to differentiate? You don't know? Okay, never mind. Jared, continue it for him. Plus pi. Agree? 4 checking it. So 4 y should be 0 because why will pi differentiate to become 0? Because pi is a number, okay? So pi being a number, constant rule tells you that when it's a number, it will become a 0, right? So be careful about that. Okay, then so because it's a 0, actually you need not write that down. Okay, so it is easier when you have to handle fractions to actually re-express it into negative indices. Then after you bring down the negative 3, so negative 2 times negative 3 you get positive 6. Negative 3 minus 1 you get negative 4. Okay, depending on the question, sometimes they may insist that you leave it in positive index form. But I also encourage you to have the habit of leaving answers in positive index form. So this will be the answer here. Okay. For part B, alright, at this point, okay, we only have a limited set of rules. We will not be able to handle this, okay, with the rules that we have. I mean, we don't have a quotient rule and all that to handle any division. But okay, what we can do is that we can simplify this expression actually. Okay, so to simplify this expression, we can see it like this because this is what we understand about algebra. So upon simplification, I will get individual terms like this, right? Okay. Then after that, this one, the x is at the bottom, so let's re-express that. Okay, to arrive at this. Then, x over 2, by the way, is half x, if you need to see it in that form. Okay, so differentiating it, half x will become half. Negative 3 over 2 differentiate to become 0. 7 over 2x power negative 1 will be where you bring down negative 1. Negative 1 minus 1, negative 2. Okay. So to simplify everything, your final answer will be half minus 7 over 2x squared. Okay. Next week, I will continue with this section. Then after that, I'll also introduce to you your quotient rule, product rule, for you to handle more difficult ones. Okay, I know that having to go through a math lesson at this time is not an easy one. Okay, I hope that you